Okay, we're going to be starting on chapter 9. Now, a lot of the work that we're going to do from chapter 9, we're not going to do from the book. You had some worksheets that I sent home in that green folder. No, orange folder. Y'all's folder was orange. You have some worksheets that I sent home in the folder that had your notes in it. There was one that was prisms and on one side, cylinders on the back. There was another one that was pyramids on one side and cones on the back. We're going to be using those for a big chunk of the work for this chapter instead of doing the problems from the book. Okay, so we can go through that and hopefully get through this chapter a little bit faster. Okay, so that's what we're going to be working on. But for right now, this section, we are going to use the book. Okay, section 9.1, pages 400 through 402. And one of the main things that it talked about in section 9.1, there on page 398, was Euler's formula. We're talking about three-dimensional figures in this chapter. Okay, so normally most of them that we've done so far have been two-dimensional. You had length, you had width. Or you had base, you had height. These have three dimensions. They have length, width, and height, okay? So with these three-dimensional figures, and they give you several pictures of them at the top of page 398, we're going to be working with them. And one particular formula specifically today, and that is Euler's formula, which it has it there on page 398, okay? It says the number of vertices, which is the number of corners where the sides meet, minus the number of edges, those are the actual lines to sides, plus the number of faces should always equal 2. Okay, for any of our three-dimensional figures that we're going to be working on, these convex polyhedrons that we're going to be working on, the vertices minus the edges plus the faces should equal 2. Okay? Now, a vertex is like the points. Now, I'm going to go grab some of our three-dimensional figures that we use. Okay, and I've just got a couple of them. Remember, our vertex are the points, the corners. So this is a vertex, this is a vertex. This, okay, so I've got the 4 vertices that are on the bottom, plus this one. So there's 5 vertices, okay? It's vertices. Edges are the lines where the two sides meet. So there's an edge here, edge here, edge here, edge here. So you got 4 going around here. Then you also have 4 edges going around the bottom. And then faces are the actual sides, the actual flat sides. So there's 1, 2, 3, 4 of those going around and 5 on the bottom. So it's saying when you take the number of vertices minus the number of edges plus the number of faces, it should always equal 2. So that's what we're using for like the first 7 problems that we're doing today. Okay? So, the first thing it says on number 1 is true or false. Euler's formula can be rewritten as vertices plus faces is equal to edges plus 2. So if you look closely at this, the only difference is they moved this E to the other side. It was a minus on this side. When they moved it to the other side, it was positive. So is that still equal to the same thing? That's still equal to the same thing. So it's going to be, for number 1, it's going to be true. Okay? Number 1 is true. Okay? Now, number 2 is where we start having to count them, okay? And like I said, we have the different ones. I intended to get all these out earlier, but my other class had issues. So, all right. So this looks like the picture you got for number 1. Okay. This is a cube. All the sides are the same. The first thing we got to do is we got to count the number of vertices. Vertices, remember, are the corners. So how many vertices do we have going around on the top side? 1, 2, 3,
4.
4 on the top. How many are on the bottom?
1, 2, 4.
4. So we have 8 vertices minus the number of edges. So the number of edges, 1, 2, 3, 4 going around the top. And then 1, 2, 3, 4 going around the bottom. So there's 8. But then I have the ones that connect the top and the bottom. So 9, 10, 11, there's 12 edges. 12 edges. And then faces, how many sides does the cube have? Top and bottoms, 1 and 2. Front and backs, 3, 4. Left and rights, 5, 6. So 8 minus 12 is what?
-4.
-4 plus 6 is
10. 2.
2.
I meant
Is that
2.
what it's supposed to equal?
2.
Yeah. And I just wrote all those up there wrong. Okay, this is 8. This was 12. This was 6. And then you're supposed to do this part down here. I just got carried away and did it all in one thing. There you go. I was just doing it all at once. All right. They want the number of vertices, the number of edges, the number of faces, and then they want you to make sure it worked with Euler's formula. I was just trying to do it all at one time. Okay? Now, number 3. Okay? On number 3, it's a different size. It's a different shape, okay? So you've got to count what you're doing. So you're going to count the ones at the top, okay? Going around the top, and then you know it's the same on the bottom, right? You count the ones on the top, and you know it's the same on the bottom. So when you're going to do this, the number of vertices going around the top, those little corners, you pick one to start at and go around. 1, 2, 3, 4, 5, 6, 7. I got 8 going around the top. And then you double it for the bottom, so that's 16. And then for my edges, the top, 1, 2, 3, 4, 5, 6, 7, 8. I got 8 on the top edges, 8 on the bottom, and then 8 connecting them, so that's 24 edges. And then my number of faces, I got 8 sides going around, and then the top and the bottom, so there's 10 faces. And then I try my formula, 16 minus 24 plus 10. 16 minus 24 is going to be -8. -8 plus 10 is 2. So it worked with Euler's formula. So basically, you're just using Euler's formula to check and see if you counted your vertices, edges, and faces right. I've already clicked on that before. I don't know what their deal is, but they're not logging in. All right. Number 4. We're counting vertices. We're counting vertices on number 4. On the top, I see 4. Going around the middle, I see 4. And then on the bottom, I see 4. So there's 12 vertices. Edges connecting those vertices together. There's 4 going around the top. There's 4 going around the middle. There's 4 going around the bottom. Plus you got the ones connecting the top to the middle and then the middle to the bottom. So there's another 1, 2, 3, 4, 5, 6, 7, 8 with the others that I'd already counted. So there's 20 edges total. And then the faces or the sides. So you all count those for me. You know, it popped up that Mia was trying to join. I clicked on it, but then it never showed her.
There's 10.
There's 10 faces.
Maybe. I don't know.
You've got 4 going around the top half, 4 going around the bottom half, and then the top and bottom. So yes. So I have 12 minus 20, which is -8, plus 10, which is 2. So that's correct with Euler's formula. Okay. And then number 5, that's a type of a pyramid. You need to count all the vertices around the bottom first. Okay, I need more than just Javier counting, and there's some of you that I'm getting ready to kick you out of the meeting because I keep just seeing your screen, no camera. And so you're gonna be gone. So I need people counting other than just Javier for how many points are there, the vertices.
Nine.
Okay, I got 10.
I got 9.
You got 9? All right, because there's 1, 2, 3, 4, 5, 6. Because it's got, what, 9 sides around the bottom? There's 9 sides around the bottom, so you got 9 down there plus the one at the top.
Oh.
So it's 10. And then the edges, you'll have the 9 at the bottom and then the 9 connecting the bottom to the point at the top. So that's 18. And then the faces, we already said there's 9 sides going around the bottom. So there's 9 little skinny tall triangles going around plus the base. So that's also going to be 10. Okay. So now we do 10 minus 18 plus 10. That's equal to 2. So we're good. So we're almost done with these. Then we go to the next type. Okay. Number 6. Vertices. You got the point at the very top, point at the very bottom. That's 2. Then the figure that's there in the middle looks like a pentagon, 5 sides. So that's 5 vertices there. So 5 plus the one at the top, one at the bottom is 7. Then for the edges, you've got the 5 that go around the pentagon. And then you've got the 5 connecting the pentagon in the middle to the top. And the 5 connecting the pentagon in the middle to the bottom. for a total of 15. And then the faces, you've got 5 triangles on the top, going from the pentagon to the top vertex, and then 5 triangles on the bottom, going from the pentagon to the bottom vertex. So there's 10. And so if I take 7 minus 15 plus 10, 7 minus 15 is -8. -8 plus 10 equals 2. So it worked with Euler's formula. Okay. And then number 7, vertices, you've got the little triangle at the top, so there's 3 there. Then you've got 1, 2, 3, 4, it looks like 5 around the bottom. It's a pentagon on the bottom. So 3 plus 5 is 8. For the edges, you got the 3 triangles around the top. You got 5 around the bottom, and then you've got connecting the top and bottom together. So there's 8, and then there's 9, 10, 11, 12. How many edges are y'all getting? That's all the lines, both the solid ones and the dashed ones.
I don't know. That's a lot of lines. Maybe 14.
That's close.
16.
16. Okay. And for the faces, you got the top and the bottom, and then you got the ones going around the side. I'm getting 10.
Yep.
So I have 8 minus 16, which is -8 plus 10 equals 2. So it works with Euler's formula. Okay. So for counting the vertices, remember, are your corners. Edges are the lines where the 2 sides meet, 2 faces meet, and then the flat sides are your faces. Okay. Now, for 13, 14, 15, and 16. For 13, 14, 15, and 16, we're not having to count vertices, faces, or edges. On those, it says identify the cross section of a cube formed by each described plane. So first of all, remember this is a cube, right? This is a cube. Okay, so I'm going to talk about a cross section. Now, if you look right here, it shows different cross sections. It's when they take a plane and they cut across the 3-dimensional figure. You're telling what shape it's making when that plane goes across there. So if it was parallel to the base, it gives you the shape of the thing, a circle. If it's diagonal, then it gave you kind of an oblique thing. If it was going straight up and down, you see what it did? So it gives you different shapes depending on which way that plane is turned. That's what we're figuring out on 13, 14, 15, 16. What we think that shape would look like. Okay? Okay, Javier, or Pedro, whoever. All right, so on there, on 13, it says a plane parallel to the top and bottom faces. So that means a plane, think of a plane as like a sheet of paper. If I take a sheet of paper and cut it right through the middle of this, what shape is that going to give me? What shape?
Square.
Just a square. Okay, if I have a plane that's parallel to the bases, it's going to give me the shape of the base, which is the shape of the base of a cube is a square. Now, it says on 14, the plane containing the left front edge and the back right edge. So it's going from the left front to the back right. So it's going diagonally through here. And you're trying to figure out what shape that's going to make. Anybody have a guess? What's that look like down there in that picture? What shape does that look like?
A triangle?
No, the shaded part.
Oh,
Not a triangle, but a
Rectangle.
rectangle. If it goes from the front side on one and to the back on the other, it's going to be a rectangle. Now, 15. A plane containing the diagonal of the left face and only one vertex of the right face. So that means diagonal, remember, goes across it. So it's going from across this thing down here to just this bottom point. So it's cutting this side in half. So am I going to get a rectangle again? No. What do we get if we cut a rectangle in half? What shape do we get?
Square.
If I take a rectangle and cut it in half in the diagonal, I get a
Triangle.
triangle.
Yep.
Okay. Number 16. A plane containing a diagonal of the top face and a segment of the bottom face that is not its diagonal. So I'm going to show you the picture that they have in the book, and you tell me what you think that is. What shape is that? Everybody see? What shape is that? What's shaded in number 16? What shape?
Rhombus.
A trapezoid. Trapezoid. Okay. So that's what it's talking about with the cross sections. And it's hard to see those unless you actually have a picture, because it's hard to visualize those. Okay. All right. Page 401. Page 401, 17 through 22 is talking about the Anita biscuit boxes. Okay. Apparently they were a type of biscuits. Okay. The Anita biscuit boxes ordered by the National Biscuit Company in 1896 individually packaged food products. Okay. So the Anita biscuit box. Okay. So
You need a biscuit.
what?
It says you need a biscuit.
You need a biscuit. That's just I can't say it that way because that's just weird. That just sounds dumb. But anyway, I know that's probably what it is, but it just sounds dumb. All right. So you have this right here, right? That looks like this box that they have in the picture. Everybody see the box in the picture? Ooh, you see this? Does that look like the same shape? Yes? Does that look like the same shape?
Yeah.
Yes, ma'am. Yep.
That is called a what? What shape is this? It is a square.
That's a square.
A square prism.
Yep.
Yeah, that's the name.
Yeah, well, thank you. It is a square prism. Okay. Now you'll notice next to the problems, they have something laid out flat. Everybody see that? That looks like this. Does this look
Yes.
like what they have there?
Yeah.
This is what they call the net. If you had done your notes, this is the net for a square prism. It shows what folds together, what pieces come together to make the square prism, the box. Okay, so it gives you the net there in your book with the different dimensions, and that's what we're going to be using to solve the rest of these. Okay, so on number 18, it says state the number of vertices, edges, and faces of the box. So remember, your vertices are your corners. So how many corners does this have? 1, 2, 3, 4, 5, 6, 7, 8. There were 8 vertices. Edges are the lines. You got 4 lines, edges on the top, 4 on the bottom, 4 connecting the top and bottom together. So that's 12. And then for your faces, you got the top and bottom, the front and back, the left and right. So there's 6 faces. Okay, you have 8 vertices, 12 edges, and 6 faces. Okay, I'm going to roll you over a little bit so you can see those. Whee. All right. Number 19. How many square inches are available for the National Biscuit Company logo on the top of the box? Okay, so to find the top of the box, you're finding the area, right? The inches. It's calling this the top, this little square. Okay, so on your net in the book, this little square has what dimensions going across here? That's what I'm going across is 3 inches, and then the one going down here is also
3 inches.
So the area is 3 times
6.
3, which is 9. You don't add for area, you multiply for area. You multiply the 3 times the 3 and get 9.
My multiplication is bad right now.
Number 20. How many square inches are on each lateral face? So the lateral faces are these longer rectangles that make these sides. Okay, so there's 4 of those, right? But it wants to know the area for those. This is still 3 across, but how far does it say it is going up and down over here on your net?
6.
6. So to find the area for one of those, you take 3 times 6 and get 18 square inches. Okay. Yes, no.
Yep.
Okay. Now, for number 21, it says, assuming no overlap, how many square inches of wax paper would be needed to line the box? So if I'm lining the box, that's covering every inside of the box. So that's taking all of this together. So pretend this is my wax paper. I'm lining the box. So it's going to take 4 of those big rectangles and then 2 of the little squares to line to cover everything inside that box. So what was the area of the little squares?
9.
And there were
9.
9.
So I have 2 times 9. The area of the big rectangles was 18, but how many of those were there?
4.
So I have 4. And 18, and then I'm just going to add those 2 answers together. Okay, so 2 times 9.
18.
18, my marker's dying. Okay. 2 times 9.
18.
It's 90.
And 4 times 18 is,
72.
so you got 90 square inches of wax paper. All right. 22. If the package were designed as an octagonal prism, octagonal means what? Octagons, how many sides?
8.
8.
So it's like this, but it has 8 instead of 6. This one only has 6. So it's going to be something like this. Okay, but it's going to have 8. Octagonal prism, octagonal shape of the crackers. How many edges would the package have? So it's just edges of the octagonal prism. So it's going to have how many going around the top? If it's an octagon, we said it's 8, right? How many is it going to have going around the bottom?
8.
8.
And then how many going connecting the top and bottom together?
8.
8. So 8 plus 8 plus 8.
32.
24.
24.
Okay. So it has 24 edges. Okay. Now, number 23. It says complete the table listing the number of edges of a prism's base and the prism's number of vertices, edges, and faces. Okay. So we'll come back to that one in a minute. Then the table. So let's skip down to 28 through 31. Okay. So we're on number 28. On 28, it says, use Euler's formula and the fact that each edge is the intersection of 2 faces to find the number of vertices for each convex polyhedron with its described faces. So, use Euler's formula and the fact that each edge is the intersection of 2 faces. So what you're going to do is you're going to take, for number 28, it says 8 triangular. How many sides does a triangle have?
3.
Great.
3.
What? So, you have 8 times 3, and you're going to divide that by 2. Because it takes 2 faces to make an edge. So 8 times 3 is what?
24.
24.
4 divided by 2 is?
12.
12.
So now we plug into Euler's formula. Euler's formula, remember, is the vertices, which that's what we're looking for, minus the number of edges, which we just found was 12, plus the faces, which is how many sides it gave you in the beginning, 8. And we know that's equal to 2. And then you work backwards to find V. Okay? So V, what is negative 12 plus 8? Negative 4, maybe?
4.
I think so.
Yeah, I bet that.
And then I'm trying to get V by itself. How do I get rid of subtraction?
Addition.
So I add 4 to both sides, so the number of vertices will be
20.
6.
So that's what we're doing on 28, 29, 30, and 31. Okay? So 29. 29 says you have 12 pentagonal faces. So pentagon has how many sides?
5.
So I have 12 times 5 divided by 2. So 12 times 5 is
70.
60 divided by 2 is 30. And I plug in my vertices minus, I got 30 edges plus 12 faces is equal to 2. Negative 30 plus 12. Y'all are terrible with your positive and negatives, apparently.
18.
So I've got b minus 18 equals 2. I add 18 to both sides. So the number of vertices is 20.
20.
Okay. Number 30. Number 30 says there are 20 triangular faces. So we're going to do like we did on number 28 and 29. You have 20 times how many sides does a triangle have?
3.
3 divided by 2. So 20 times 3.
60.
60 divided by 2 is
30.
30. So I have vertices minus 30 plus 20, because there were 20 faces, is equal to 2. So negative 30 plus 20 is negative 10. I have subtraction, so I'll get rid of it by adding. So the number of vertices would be 12. Yes?
Yeah. Yes, ma'am.
So number 31. Number 31, that's what we're doing next. Okay. On 31s, it says that there are one triangular, no, I'm sorry, that's 33. We're not doing 33. It has 3 rectangular. So I have 3 times 4, because there's 4 sides in a rectangle. Right?
Yep.
Plus, this is number 31. Then it says there's 2 triangular, so I've got 2 times 3 for the triangles and divided by 2. Now I had to do 2 separate ones added together this time because part of them were rectangular and part of them were triangular. So 3 times 4 is 12. 2
Those
times 3 is 6. 12 plus 6 is
18.
18. Divided by 2 is 9. So my number of edges is 9. So I have my vertices minus my number of edges plus my number of faces. My number of faces is, there were 3 of these and 2 of these. So 3 plus 2 is
5.
5. And then that's supposed to equal 2. And then we finish simplifying. So I have v negative 9 plus 5 is negative 4. And then add 4 to both sides. So my number of vertices is
2.
That was number 31. Okay. So we have finished everything except number 23 up to this point. So let's look at number 23. We'll finish up. You are working on 23 and getting it done. Okay. On 23, it says the sides of the base are 3. Okay. The sides of the base are 3. So it means its base is what shape? Triangle, right? Sides of the base are 3. So how many vertices does it have?
1, 2,
3.
4, 5.
12.
4. Wait.
Oh, wait, this is supposed to be a prism, not a pyramid. My bad. Hang on.
Wow.
Oh. All right, size of the base is 3, but it's a prism. It goes this way. Ta-da. All right, so there's 1, 2, 3 vertices at the top. And 1, 2, 3 vertices at the bottom. So it's got how many vertices?
9.
6.
6.
Base.
How many edges?
1.
There's 3 going around here. There's 3 on the bottom. And then there's 3 connecting them.
9.
There's 9. And then how many faces, sides does it have? Top and bottom. Then
6.
going around
5.
5. So we would have 6 vertices, 9 edges, and 5 faces. Now the next one says the sides of the base is 6. Sides of the base is 6. That's hexagon. That's this one. So if the sides of the base is 6, vertices it says was how many? It gave that to you on the table. You shouldn't be guessing. It gave you that.
12.
12.
The vertices is 12. Okay. How many edges?
1, 2.
That's a lot.
6 on the top.
12.
On the bottom.
24.
And top and bottom. That's not 24.
18.
18.
Boom.
And then the number of faces is 8 because you got the 6 sides and then the top and the bottom. Okay. Now this one says the sides, it gives you that it has vertices is 24. Now you should notice a pattern. Look at your sides of your base and your vertices. The vertices is always how many more?
12.
Huh?
12.
No. The vertices is not always 12 more. Look at the
1 more.
Don't talk, listen. The vertices, I had 6 vertices when there were 3 sides on the base. I had 12 vertices, there were 6 sides on the base. I had 24 vertices, there were 12 sides on the base. So the number of vertices is always 2 times the number of sides on the base. This had 6, so it had 12 vertices. This had 3 sides on the base, it had 6 vertices. So it's 2 times whatever it is. So when you're doing that last row, if the sides of the base is in, your vertices is going to be 2 in. So the last row, this is your last row for 23. You got, it gave you in, so the next one is 2 in, 2 times in. Okay, the next one is 2 in. Okay, then look at the edges. The edges was always what compared to the first number in the table? When this was 6, the number of edges was 18. When this was 3, the number of edges was 9. So instead of multiplying by 2, you multiply by 3. So your next one is 3 in. So I got 2 in, I got 3 in. And then the last one, if you look at the sides of your base and your number of faces, sides of the base was 3, number of faces was 5. Sides of the base was 6, number of faces was 8. Sides of the base was 12, number of faces was 14. So they take whatever the sides of the base was and add 2 to it. So your 3 answers on the bottom row, 2n, 3n, n plus 2. So you should have all of 1 through 7 done, all of 13 through 23 done, and all of 28 through 31 done. So we got just 34, 39, 40, 43, and 44. We got 5 more problems to do tomorrow. Okay? If you have not filled out your chapter 9 notes, make sure they're filled out. If you have not tried to send me your chapter 8 test, then you need to send that to me.
I tried to send it into them, miss.
Yeah, you better.
I barely bought my phone yesterday.
I didn't send you one page because I didn't do it. Because I didn't know how to.
All right, so everybody knows what they need to do. Go get it done.
Okay.
All right, miss.
No tacos.
I'll pass by your house today if I need help.
Yeah.
Yes.
All right. Bye, Miss Paula.
Bye.